Hello and welcome back to the R Bootcamp. We are in the fourth and final video of Module 1, working with data objects. And where we're going to start is on the website where it says making up data. We're just going to get some more experience building up data objects and working with data objects before we get into the next module, which involves reading in real data sets and working with real data sets. Let's go back to RStudio, and if you go to the comment where it says making up data, we'll get started. Now, we've already seen some ways to build up sequences. In particular, we've seen this colon operator, which just kind of fleshes out a sequence of integers. So this will give a sequence of integers from 1 to 10, and we can run it and just get that sequence. We can actually do that in reverse. So this gives the sequence from 10 to 1 of all the integers in between. And we can actually use a function, this rev function, or for reverse, to also get the same order, 10 to 1. Oh, again, I just typed in the function name. If you type in the actual function with an argument, you get the reversed order sequence. Another way to create sequences is to use the seq function, seq for sequence. Now, this function is very flexible. It's more flexible than the colon operator. So this time we can give it a starting value, an ending value, and the interval that we want the sequence to have. So the interval between every element in the sequence. And that's another way to get 1 to 10. But we could get 1 to 10 in units of 2 if we wanted to. And of course, that if we start at 1, we get 1, 3, 5, 7, and 9. We can't get 10 because that's not actually, like, since 9 isn't a member of that sequence, 10 is only 1 away from that, so it doesn't give us actually 10. We could go from 0 to 10 in units of 2, and then we'd get 0, 2, 4, 6, 8, 10. So that makes it a little more flexible. We could do the reverse, make a sequence from 10 to 1 in units of -1, which is going to give us the same 10 to 1 sequence. We can specify the length instead of the interval between the elements. So here we're saying we want a sequence from 1 to 10, and we want the final vector to be length 10. That's often quite useful, and it gives us, of course, the same sequence. And we can, in this case, say, okay, we want a sequence between 0 and 1. We want the length to be 10. So this is actually going to give decimals, because we're going to break up the interval from 0 to 1 into 10 increments. And so we will get 0.11, 0.22, all the way to 1. So again, a really flexible, powerful way to generate a whole bunch of different types of sequences. Sometimes we want to generate repeating sequences. We can use this rep function to generate repeating sequences. So in this case, we're going to repeat the value 0 3 times. 0, 0, 0. Makes sense. This time we're going to repeat the sequence, or this vector, 1, 2, 3, we're going to repeat that 2 times. So it'll be 1, 2, 3, 1, 2, 3. Let's run it. There we go. We can also repeat this vector, 1, 2, and 3. We can repeat each of those elements 2 times. So this time we're going to repeat 1, then we're going to, so it's going to be 1, 1, 2, 2, 3, 3. Let's run that. There we go. So lots of different ways to generate different types of sequences, which is a task that comes up quite frequently. We'll get back to that, but let's first talk just a little bit about random number generators. Another useful way to generate data that we can use to test functions, we can use to test other methods, it's useful to be able to generate numbers like this. We can generate random numbers from any different random number generator that we'd like. This first example is a random normal distribution where we're going to take 10 random numbers from a standard normal distribution with a standard deviation of 1 and a mean of 0. So let's do that and just look at what happens here. So we've called this vector z, so let's print out what's in z, and we get a bunch of random numbers. Now, if you run this code, obviously, you're not going to get the same numbers because the definition of randomness is that every time you do it, it's going to be a little different. So your numbers will look different, but try it along and see what you get. Some of these numbers are negative, some are positive, and the mean should be something around 0. We could even test that and just look at the mean of z, and it's 0.7. But if I run this again, I can just like use the up arrow just to get to previous things that I've run. Let's create z again and get the mean. It's 0.2. Do it one more time. It's 0.35. So it's just changing every time. It seems like at some point it would be negative, but there we go. There's a negative. But it's random. All right. We can specify the different parameters of this distribution. So we say we're going to create 10 random numbers. They're going to have a mean of, well, they won't necessarily have a mean, but they're generated from a distribution that has a mean of -2 and a standard deviation of 4. Let's run that and see what happens. So now the mean should be around -2, which it is, something like that, and the standard deviation is fairly large. So it's worth playing around with random number generators. They're super powerful, really easy to use in R. If you want to learn more, obviously, you can just do the question mark, R norm. This is for generating random normal deviates. Let's look at that. Now, we can look at the help file and see, well, this R norm, you give it the number of random numbers you want to generate, the number of observations, you give it a mean and a standard deviation. And, if you specify, if you don't specify the mean or standard deviation, it will assume that it's in this order, the order that you see in the help file. So it'll be expecting to see the number of observations, then the mean, then the standard deviation. So let's just do that real quick. So our norm, let's take 10 random numbers. The mean is 5 and standard deviation is 2. Let's look at that. There we go. Now, we could, if we wanted to, specify that we could say the standard deviation first, but to do that, we'd have to say SD equals 2 and mean equals 5. And that way, even though we're not specifying it in the order that R expects, we're naming the arguments, so R knows that this is the mean argument here, and this is the standard deviation argument here. So let's just run that, and we should get similar numbers. All right. There's a lot more to know about random numbers, but let's move on to a couple other distributions before we finish our discussion on random numbers. This is a binomial distribution, which you can think of as a coin flip. If it comes out heads, it's a 1. If it comes out tails, it's a 0. There's only 2 possibilities. And you can repeat this many, many times, and you count up the number of heads, for example. So say I flip 5 coins and I count up the number of heads. Well, the value could be 0. It could get 0 heads, and it could have a maximum. If all of the flips came out heads, then it would be 5, and it could be anything in between. So this will come up with random numbers between 0 and 5 if I do 5 coin flips. Here I'm doing 3 coin flips, so it'll come up with numbers between 0 and 3. And here the probability of heads is 0.5 or 50%. let's run that and see. Okay, we get, the first time we did this experiment, we got 1 out of 3 heads. Second time we got 0 out of 3 heads. Third time we got 2. Fourth time we got 2. Fifth time we got 2. You got something different because these are random numbers. And of course we can specify the parameters. You might want to do get the help file on random binomial just to learn more about what order that R expects. It expects to see the number of random deviates that you want, the number of coin flips essentially, and the probability of coming out heads, or the probability of success, so to speak. So here we're going to take 5 random binomial numbers. We're going to just create 5 numbers that come out of this distribution where you have 3 trials and a probability of success is 0.1 or 10%. There we go. This time I, by random chance, got all zeros, but if I run it again, I still get all zeros, and if I run it again, I get one that had 2 successes. This time I will get 5 random numbers, and I'll flip the coin. Let's just flip the coin 10 times this time, and we'll count up the total number of successes. And the chance of success is 80%, so we should get some larger numbers, and we do. And if I wanted to, I could create lots more random numbers. I'll create 50 random numbers. So it's super easy, super flexible, good thing to get used to. Another distribution that you might want to be aware of is the uniform distribution. Here we're going to get 10 random uniform numbers, and if we don't specify any parameters, it assumes that we want a uniform between 0 and 1. So we should get 10 numbers between 0 and 1, random numbers. And of course, if we wanted to, we can specify, maybe we don't want it between 0 and 1, we want it between -1 and 1 in this case. And then we can get random uniforms that meet that. And again, if you wanted to learn more, you can do $RUnif and learn more about this distribution. All right, let's move on to one more random number generator that is also very useful and flexible. It's called sample, and this just allows us to sample from a vector randomly. So here we're going to sample randomly from this vector of integers between 0 and 10. We're just going to grab one randomly from this vector. It could be 2, could be 8. Grab it randomly, record it, put it back, shake up that vector again, grab another random number, and we're going to do that 5 times. So we get 5 random numbers between 1 and 10. There we go. And we could specify that some of these numbers are more probable to grab than others. So we can specify the probability of each of those sampling each of those elements, and the probabilities we're going to specify are like this. So it's more probable to grab the larger numbers and less probable to grab the smaller numbers. And so we should get a biased sample here, biased towards larger numbers. There's a lot more to do with sample. Sample is what we can use to do bootstrapping, if you know what that is in statistics. It is a super powerful way to do all sorts of randomization trials, permutation tests. Really good function to know. All right, now we have some tools to work with. Let's build ourselves our own fake data set. And when I say data set in R, we're usually talking about this DataFrame object, which is the central data storage object in R. So we're going to make a DataFrame, and we're going to use the DataFrame function to do that. We can name each of the columns of our DataFrame this way. So we're going to have one column that's the observation ID, and we're going to have 100 observations. Each one has a unique ID. There are our unique IDs. We're going to put that in our DataFrame. We're going to say that this is like an ag experiment, for example, where there's a bunch of different treatments, and we're kind of monitoring the total number of plants that germinate from a plot, and we're recording the average height of the crop plants, for example, in a plot. And we're going to do this randomized block design where we have maybe 5 different treatments. We can say they're different types of fertilizers. And within each of those treatments, we have 20 blocks where we are collecting data. And so the treatment, we're going to use this rep or repeat to generate repeated sequences. We're going to take this vector of just characters from A, B, C, D, and E. Oops, sorry. That's what the vector looks like. Vector of length 5, and each of those we're going to repeat 20 times, and that's going to indicate the treatment that each of these observations belongs to. So each of these treatments occurs once in each block. To create the block variable, we're going to use the repeat function again, but this time we're going to use the times argument instead of each. So we're going to take this vector 1 through 20, and we're going to repeat that 5 times. So it's going to be 1 through 20, 1 through 20, 1 through 20, so on and so forth. And that's what the block variable is going to look like. Again, just using these sequence generators. Germination, we're going to use a random number generator, and this time we're going to use a random Poisson generator. Don't worry too much about what that is. It's just going to generate integers, and so we're going to give it a different set of mean values. So we're going to actually build a data set where the treatment matters. And so for every treatment, we're going to give the germination, the mean germination rate, a different value, so that there are ultimately signals that we can detect in this data set. So we're going to generate 100 random Poisson, but the means of the germination number germinated is going to vary by treatment. So it's going to look something like this. We're going to get 100 values. And we're going to do the same thing with height. And again, height is going to vary with treatment. And so we're going to build a data set where we actually have some signal to detect. If we were to build a model with these data, let's put everything together. And now we have a data frame. And it's called my.data. And it has 100 observations with 5 variables. If we want to look more into this, we can say, okay, that's what the data set looks like. We're just going to use this head function, which grabs the top few observations. We can just look over the data set we just generated and say, yep, it looks just like we thought it would. If we want a little more information, we can use summary, and we can look at this data frame. We can see some summary statistics for each of these columns. Observation ID, treatment, you see, has 5 levels, 20 each. Block, it's thinking of block as a numeric, so it gives you a mean and median, which we might want to think of block more as a factor if we wanted to. So we could, if we want, make a factor variable here, and that way when we take the summary, we see that block now has 6, no, it has more, but it's not going to show it in the summary right here. It's going to have more values, but it gives you a different type of summary. Different types of columns give you different summaries. Germination is a numeric, so we're going to get means and quantiles as by default from the summary. Anyway, just a way to look at what we have to work with. All right, and that's where we're going to end for now, because the next module is all about data and working with real data. So we'll do a lot more with that. Let's just briefly cover indexing, subsetting data sets, which is an operation you will do all the time. So it's really useful to get good with this. First of all, let's look at grabbing particular elements from a vector. Here we'll make a new vector. dvec is all the integers between, inclusive between 2 and 10. There we go. And let's grab the third element. So this is first element, second element, third element. So to do that, we use this bracket, and we take the third element of this vector, and it's 4. We can, instead of just grabbing a single element, we can grab multiple. So here we're going to grab the first and the 5th element of dvec. And so that should be 2 and 6. All right. And another thing we can do is if we use the bracket operator but we use the minus sign, that actually removes the 3rd element of the vector. So this is dvec without the 3rd element, which means it should be without 4. So it's now 2, 3, 5, 6, 7, 8, 9, 10. All right, let's make a new vector. This vector is just 1, 2, 3, 4. One kind of cool thing we can do with vectors is we can name all the elements. And this time we're going to give them literal, like human names. So I'm going to name every element of this 4-element vector with human names: Fred, Sally, Mimi, and Terrence. And we can see what dvec looks like now. Each of those elements, instead of being element 1, 2, 3, and 4, although it is still, we could still use numeric. Like this first element here is still the first element of the vector, but we can also use their names to actually extract those elements from the vector. So if we wanted to get Terrence only, we can use this character string, Terrence, and actually get Terrence back from this vector. Because it's a named vector, it makes it really easy and intuitive to be able to subset and grab elements from this vector. We can grab, of course, more than one. We can grab Sally and Fred together, and there we go. So good to get familiar with how to access elements of a vector, including named vectors. All right, let's look at a matrix. So let's build a matrix, and this time, note that we're using the matrix function. We're giving it a bunch of numbers that we want to be part of the matrix, and we're giving it just a couple arguments, 3 and 2. Now, we're not naming those arguments. We know that R is going to expect the number of rows and the number of columns. Now, if you don't know that, what are you going to do? Just use the question mark matrix, and that gives you an ability to know, okay, row comes first, then column. So we don't need to name it, but sometimes it's useful to. And so we could say n row equals 3, and n column equals 2. And we could even name the first one data. So it's often a good idea, just as you're getting familiar with using functions, to name the arguments just so you know what's going on. As you get more and more experienced, you can drop them if you know what order R expects those arguments to come in. If you don't, you can look at the help file. But let's build our own matrix. Looks like this. And if we want to access elements of a matrix, we've already done this, but let's access, say, the 3rd row and first column should be 3. Here we go. Now we can access the whole second column. If we leave the row element blank, we just specify column 2. That's going to give us all the rows in column 2. So let's run that, and it gives us the second column. So that's kind of a way to get a slice out of a matrix. You can do the same thing with rows. So this time we're going to get the second row, which should be 2 and 5. Here we go. And we can get the second and third row. We don't have to specify just one row or one column. We can specify multiple at the same time. And this time we're going to get the second and third row, which looks like 2, 5, 3, 6. There we go. All right, now in data frames, we can access elements in the same way if we want. So we can take my data, and we can get the 14th row and 3rd column, and there we go. So we can access particular elements. Now this is a factor, this row, if you remember, head of my data. This happens to be a factor. We made block a factor. So when you call a factor variable, it also returns the number of levels in that factor, and we have 20 different blocks, as you recall, so that's why there's 20 different levels. All right, now so you can access rows and columns of a data frame just like you can a matrix, but there's a couple other things you can do with data frames. One of the really important things to know with data frames is you can access elements, you can access columns by using this $ operator, and that's true for any list object. And remember, data frame is just a type of list. So any list object, you can access the elements of the list just by using this $ operator. And RStudio will conveniently, when you start typing that $, it'll let you choose which column you'd like. So I'll choose the germination column, and that gives me the germination column. So that's one nice thing we can do. So that's equivalent to this. Now the same thing can be done by using the double bracket operator and just using this text string germination. That also returns the exact same. Let me go back one step. I'm going to make this object d.df, and I'm going to assign it to be only this 10 observations from 21 to 30 of my data, just to make it easier to work with. So I'm just going to take 10 observations from my data, and I'm going to store it in this d.df object. Now we can get the germination column from this data frame, this shorter data frame, and I can get the same numbers using this double bracket notation. I can take the fourth column, which happens to be germination, so I'll get the exact same thing. And I can access the fourth element of this list, d.df, which happens to be the column germination, so it's the same thing. And if I want to, I could say I want the column of this data frame that is named germination. So it's the same thing. So there's lots of different ways to access data from a data frame, and you're going to probably use all of these ways because they all have their own little advantages. And finally, what if you use a single bracket and you use the text string germination? It gives you the germination column, but it gives it back to you as a data frame. So just be careful about that. That is a little bit different than if you use the double bracket. So we could look at the class of that object. So let's just take the class of the object that this is, and it's a data frame. Now if we took the class of, if we did the double bracket, it is not going to be a data frame. It's actually going to return a numeric, in this case an integer, because it's random Poisson, which returns an integer. All right, let's look at the average height. That's the final column of this data frame, and we can subset elements of a particular column. We'll take this is a vector, and then we'll take the third element of the average height vector, and we get 30.29, which should be d.df, the third element of height. So 30.29711, and that's what we got. So lots of different ways to access data. Again, all of them are super useful and important. Some useful functions when you are working with data, just exploring a data frame. There's some things you just kind of do almost every time you get a new data set. So length determines the length of a vector. We've seen that before. It also can give you the length of a list. So if you wanted to take d.df and get the length of d.df, it would give you 5 because there's 5 list elements, 1 for each column of your data frame. So that's how data frames work. If you wanted to get the number of observations, you would have to get the number of rows in that. So instead of using length, you would use n row, and that gives you 10 because we have 10 observations there. if you put my data in there, you'd get 100 because that was the original data frame that we built. Dim gives you the dimensionality of an object. So dim of dmat, for instance, tells you the dimensionality of a matrix, and this happens to have 3 rows and 2 columns. So if you look at dmat, you'll see 3 rows and 2 columns. So dim is good, and it's useful for arrays as well. It'll give you the number, give you the dimensionality of the array. All right. We've already seen summary, which is a useful summary of any data object. Names, we've looked at that before, but it gives you the column names in a data frame. nrow gives you the number of observations. ncol gives you the number of columns. That's the same thing that happens if you put length. If you put a data frame as the argument in the length function, gives you the number of rows. The str is for structure, and it gives you some useful summary of your data frame. Interestingly, it's the same thing you see if you look at the global environment window up here. It's the same thing. And this gives you the structure of your data object. You have 10 observations, 5 variables. Here we have 100 observations of 5 variables, and it gives you just a little summary of each column, and it includes what the data type is. So this is an integer data type, treatment is a factor, block is a factor, germination is an integer, average height is numeric. And it gives you just the first few observations so you can see what's in there. So just a nice, easy way to see what's in your data object. Before we end the video, let's go over some basic math operations. I just want to make sure you're familiar with the mathematics operators in R. We have obviously addition, subtraction, multiplication is the asterisk, division is the /, exponentiation is the caret, take the square root, just use the sqrt function, but for any other roots you need to use the caret operator and then 1 over the root you want to take. So this is the cube root. If you want to take the antilog or the or e to the power of something, use the exp function. Take the natural logarithm using the log function. The default, of course, is the natural log base e. You can change the base in the log function and just look up the help file on the log function if you want to learn more. There are some convenience log functions like the log base 10. So to get log base 10, you can use log 10 as the function name. You can also use the base equals 10 within the log function, though. Gives you the same thing. Factorial is just factorial. 5 times 4 times 3 times 2 times 1 is equal to 120. And then finally, a useful operator is the modulus operator, which it gives you the remainder after you divide the first number by the second number. So you divide 21 by 5 and you get a remainder of 1. All right, so that is the end of this module. I highly recommend you go on, take some time to look over the challenge problems, try your best to complete the challenge problems, and if you run into any questions, I hope you can join us for the live help session on Saturday. If not, feel free to email me and I can try to help with whatever your question is. And I look forward to hearing from you. Good luck, and I'll see you in Module 2.